What's up, everyone? Snowflake Dan here with you. Today we're going to be covering over how to load RDS Postgres data into Snowflake using OpenFlow. So let's get straight to it. So here on the page, you'll see a tutorial. We're going to use this tutorial for help. It's helpful to follow along any type of parameter changes and additionally any code snippets that we need for Snowflake. So let's get started. So the first thing we'll need to do is actually create an RDS instance. In my case, I don't have one, and I want to walk everyone through how that looks. If you already have an RDS instance, you could fast forward roughly a minute. So let's head over to our AWS, to RDS, and then let's go to database instances and let's create a new one. Now, one good thing to call out here is actually I want to match my RDS instance to my Snowflake instance because we don't want to get charged unnecessary egress costs. So my Snowflake is going to be hosted in Oregon, so I will match that. From there, I'll create a database. I'll select Postgres. The next question is going to be asked is what engine do I want to use with this? And so I'm happy with 17. In this case, I'm using a free tier because this is just a demo. I'm going to give my database instance a name, which will be my own name. The next will be the username to log into. We'll switch that to my name as well to make it easy to remember. We'll put in a password. Perfect. And then the rest of it can be mostly defaulted except for one specific spot. Because I am hosting in Snowflake, my OpenFlow inside of Snowflake, which reaches across the internet to get sources today, this will have to be publicly accessible. Now, if you're hosting your OpenFlow in AWS, this is not required, but just for this demo, we're not going to be going over networking. We're going to be simply going over the steps of how to connect OpenFlow to a Postgres instance. We might go over in a future video how we could do this with being hosted in AWS. Perfect. So we'll continue going on. We'll continue, and then we'll just create the database. Perfect. So now we have the database starting to be created. So one thing we could do while that's happening to save on time is actually start to create what is known as a parameter group. A parameter group is basically a way of creating settings on your database and then applying them to that database. But at first, because it's being created, we could just create the parameters to begin with. So to do so, we'll head over to parameters. And you can see I've already got one here, but I'm going to showcase how to do this. So we'll call this one OpenFlow v2, example OpenFlow as the description. We'll select the database type. In this case, it's just Postgres. And we'll select a parameter group family, which is really the version. So we'll do 17. From there, we'll click Create. And so now you can see we've got a parameter group here. What we'll want to do is select that parameter group and click Edit. Now, I don't remember explicitly what parameters are required. So that's what the tutorial is for. So here we'll scroll down. You'll see we can go through it. We've created our parameter group and we've selected it. So now we're at the point where we want to look up this RDS logical replication. And we'll notice that we want to switch the value to 1. So we'll head back. We'll put that in the filter. And here we could see we could switch it to 1 and click Save. From there, we'll click Edit one more time because we have to do one more setting. The next one is wall sender timeout. So we'll copy that again. And from the tutorial, the time we want to set is 0. So we'll switch it from 3000 to 0. We'll click Save. And then from there, we are good to go from a parameter perspective. Now, if we head back to RDS, we could see that our database has not been created yet or has not been finalized the creation. So what we can do now is actually check that our security group or our inbound and outbound traffic is allowed to come from OpenFlow. So we'll click on that VPC security group. We'll check the box, and we can go to inbound rules. Now, what I've done is that I already have an inbound rule for PostgreSQL for 0.0. That means that any IP address can actually connect to the Postgres instance, so I just kept it simple. Now, the same will have to be done for the outbound rules. So if we go back, we check the box one more time. The same will have to happen for outbound rules, which is already done today. If, again, you're just doing this for demo purposes and trying it out, this is a perfectly fine way to do it. But if you are in production, my recommendation would be to deploy on AWS, and that is the safest way to go because all the traffic is actually staying in the AWS environment. Perfect. So let's head back to Postgres, or really to RDS, to make sure or to check on the status of our database. So it's still creating, so I'm going to fast forward a little bit here to when it's done creating. Perfect. So now we can see that our database is available and ready. What we'll want to do is click on that database. We'll actually want to go to Modify. We'll wait a few seconds, and then we'll want to scroll to the bottom where we have additional options, and one of those is database options or database parameter group. So what we can do is we can switch over to our OpenFlow v2, and then we can click Continue. Now, you can either apply it during a maintenance window, or you could apply it immediately. And in this case, because it's a demo and there's no data in there, we'll apply it immediately. So we'll click Modify Database. Now, if you don't see the status of your database going to modify, I highly recommend to reboot it, just for the fact that it's actually not getting applied. But in this case, we do see that it is modifying it and it is applying. So I guess it also could be just waiting and being patient. So now that we're modifying the database, that should take maybe a minute. What we could do is we could actually click on the database, and something we'll need is the endpoint itself. So we'll copy this. Additionally, if you want the port, if you're using a different IDE than I'm about to show, you might need to copy the port as well. So we'll copy the endpoint over to a notepad, and we'll go back to our databases while it's continue modifying. Something we could do is start to get our access to it set up. So today, what I'm going to use is a program called pgadmin. pgadmin is an open source free tool that you could download. I've put the link in the description already. So if I scroll down a little bit, you can see there's a download PG. It also will show you how to connect. So let's do that. So what we'll do is we'll simply right click, register a server. We'll give it a name. In this case, maybe I call it Postgres for OpenFlow. From there, we'll go to connection and we'll have to put in that host name there. Now, in my case, I did change mine to my name, my username to my name. In this case, I'll put in the password. And we'll go back to our RDS and see if it's available. Now, we could see that the modification to it has made it available. So we could go back to pgadmin, click Save. And we can open up our database and go into it now. So here you can see we've got two databases in there. Those are system databases. We'll want to create a new one. So in this case, I can call mine Daniel Wilczak, again, to keep it straightforward and simple. And from here, what we'll want to do is start to query and add data to it. So I'll click the simple query tool, and we'll head back to the tutorial because I do provide some easy tables and schema and an insert to make it easy for you all. So we'll go there, we'll go back to our pgadmin, we'll paste that in there, we'll select it all, and we'll click execute script. So here you can see we were successful. So if we go into schemas, we can now see we have a schema called replicate, which has the tables inside of it. There we go. So you can see we've got orders, products, and users, but we still need some data in there to make sure that OpenFlow is actually going to replicate that data. So we'll head back to the tutorial, switch to insert data, we'll copy that, and we'll head back to pgadmin. Now I'm just going to overwrite this, put it in there, and say run script. And so now you can see we've inserted that data. Perfect. Moving right along. Now, the next step is that we have to set up OpenFlow because what parameters we changed was that now Postgres can have a log inside of it to track changes that happen inside of Postgres. Then what OpenFlow will do is read those changes and replicate them into Snowflake. And so the way we do that, or really the mechanism in which we do that, is known as a publication and a logical replication slot. So what we'll do is we'll copy it here. We'll head back to PG admin. We'll overwrite it. Now I'm going to run these step by step because they have to be run in steps. Additionally, we can look at the tables that we're replicating. One big thing to call out here is that in this publication, I'm just saying grab all the tables. I just want to keep it super simple. I don't want to deal with kind of the selecting, but if you want to, you could always go into the Snowflake documentation and review how to switch this to the specific tables. So here, I'll run the first one, which is to create it. Now, what it's saying is that the wall level is insufficient to publish logical changes. So it seems like our Postgres instance has not actually taken those parameter changes that we wanted to. We can go and validate that those parameters are in place. So if we head back and we go to our parameter group and we go to OpenFlow v2, click edit, what we could do is head back up into the tutorial to validate this. But more than likely what will happen is that we just simply need to reboot our RDS instance to make sure that it got applied. But here we're just going to validate, yes, it is 1. So let's head back to RDS really quickly. Let's head back to the database instance. Here, let's click on that database itself. Let's go to actions and let's reboot. Let's confirm it. Now, the reason we're doing this is just because of that error where it's not realizing that the wall log is switched to 1. So we'll allow this to reboot itself, and then we'll fast forward to where we can run that command. I just wanted to show everyone that if you run into this issue, this is kind of the step-by-step process to make sure that it gets applied correctly. Awesome. So now that we can see our RDS instance has rebooted, let's head back to here. Let's select the first one again, and let's click Run. Click Continue. It will just reconnect. And now you can see the publication has been created, so we have resolved the issue. Next, if we wanted to, we could look at those specific tables. So give me 1 second. We can see the tables that are there that are going to be replicated. And finally, we can create our replication slot. So we'll select that and click Run, and you can see that it's now good. So something to note here is that we will need these names. So something I'm going to note, because we're going to use these in OpenFlow, is the publication name and additionally the replication slot name. Perfect. So let's now head back to the tutorial, make sure we covered everything. So we have created the data, the replication slots, and now we're finally on to Snowflake. So I have nothing in my Snowflake account, so I will copy this little snippet here because this will create a database, a warehouse for us, and also a schema called network, because in my case, we will need to create a network rule to be able to connect to RDS. So what we'll want to do here is simply take this and hit run. Perfect. So now if I do a quick refresh here on the left side, you can see now we've got a database and a schema called network. Moving right along. Now again, like I said, we are going to be hosting inside of SPCS, or really Snowflake, so we do need to create a network rule. So what we'll do is we'll head back here, we'll copy over this, and what it says here is that we need to go grab our RDS URL. So I've got that copied on the side, and we'll paste it right here. And for all of those who've jumped to this point of the tutorial, to get that, you just simply click on your database and you can see the endpoint here. So perfect. So what we're going to do is create a network rule and then an external access integration, which allows us to have access to that endpoint. So I'll select both of those and I will create them. Awesome. So now we're successful. The next step is if we head back to the tutorial, it's now going to take us through the steps to set up OpenFlow. And so one big call out here is that if you do get like an invalid consent request or top invalid while you're trying to go into the OpenFlow platform by launching it inside of Snowflake, all you have to do is simply change your role to something that is not the account admin, or really what I mean is default your role to something that is not an admin role. Awesome. So let's head back to Snowflake, go to ingestion, OpenFlow, and launch OpenFlow. Perfect. So I've already got a runtime set up. If you do not, there is a helpful tutorial on our page as well here under deployments where you could select either Snowflake or AWS. Both of these take less than 8 minutes. So today I'm just going to be showcasing it on Snowflake. Perfect. So let's head to runtimes. What we'll want to do is first create a runtime. This is where the connector will live. So I'll simply call this Postgres because that's what's going to be in there. I'll select the role, which is account admin. Then I'll choose my external access integration, the one we just created. And then finally, I'll click create. Now, this will take roughly 5 to 10 minutes to create the runtime. You can either view the runtime or browse the connectors. In this case, when we browse the connectors, the one we'll want is going to be specifically this PostgreSQL one. One big call out, because I have skipped it over, and since we have a little bit of time, is when you go to create that external access integration, just make sure that at the end of it, you make sure to keep your port number. If you don't add the port number, Snowflake will not know that you want to go to that one, and by default, it will go to port 80. So just a good shout out there for troubleshooting purposes, make sure you're adding your port number. Perfect. So let's head back to the runtime to check on its status. And it is still creating. What we're looking for is it to go active, and that takes between 5 to 10 minutes. So let's fast forward. Perfect. So now that our runtime is up and running, what we could do is click into it. It will require us to click allow for the roles. And then finally, we're now inside of our canvas of OpenFlow. So what we could do is go back and add that connector. So if you go to Overview, View More Connectors, we could scroll down to Postgres, click Install, select our runtime, and click Add. It'll start installing the connector, which only takes a few moments. And now we can see we have the Postgres connector available for us. So what we'll want to do is the first step is actually to look at the parameters. Now, what are parameters? Parameters are basically the variables in which we have to put into for the destination, being Snowflake, the source, which is our Postgres instance, and then what ingestion parameters do we want to select? For example, what tables do we want to pull? What frequency do we want to merge those tables into our Snowflake? So on and so forth. So the first thing I'm going to do is the destination because it's the easiest one. So in this case, what we'll want to do is set up the database first. So in this case, it's raw. Now, if you're deployed inside of AWS, you will have to put the account identifier, additional private keys, a username. But since I'm doing it on Snowflake, there is a helpful hint here that says when you're using SPCS, you could just put in Snowflake session token and you're good to go. So I'll simply click edit. I'll put it in there and I'll click OK. We'll keep it as standard because we're not really using this again for key pair. The next thing we'll want to do is head down to the role. We'll click edit. We'll go to account admin because I'm keeping it simple here. The next is the warehouse. And if you remember when we ran our script to create everything, we called it OpenFlow. Perfect. Now everything looks good. We'll click apply. Now, even if these checkboxes go through, you might see these warning labels. These warning labels are not because you've done anything wrong. It's simply because we haven't started the connector yet, or we haven't put it into a state where it's ready to go. So we'll click close there. And the next step is let's go through the source. So we'll click on edit on the source. And the first thing we'll need to do is edit the Postgres connection URL. So we'll click edit here. And you can notice that we have that same host name again, the same one that we used during our login with pgadmin. So we'll paste that here. And you'll notice that the database name is also in there. So if you remember when I created it, it was called Daniel Wilczak. Now this is how we identify which database you want to add. If you have multiple databases, you'll have to add multiple instances of the connector. So we'll click OK here. The next thing is the Postgres JDBC driver. You might ask, what is a JDBC driver? But don't worry, you don't actually have to know what this does. You just have to know how to grow and grab one. So we'll head back to the tutorial, and if we scroll down to the section where we're at right now, we can see here on the source that we need to get this jar file. Now, we can get this jar file by simply going to download the JDBC driver from the Postgres website. So we'll do that. We'll click connect. And in this case, I'm just going to download the Java 8 version of it. It's really up to you what you want to download. And so here you can see we've got that jar file now. If we head back to OpenFlow, click edit, we can now click the reference assets, click the upload button one more time, and then we could select our jar file. Now it's uploaded, so we can click close. We can now select that jar file as well. We'll click edit and we'll click good. So next one is going to be the password and username. So if we remember, my username was simple because I kept it the same across all of them. And the password. And then finally, we'll need that publication name and slot name. So if I click edit here, it was OpenFlow_pub and the replication slot. I'll click apply. Now again, these won't turn off until we start the connector. Click close, and we'll click edit on the final section. So I'll uncheck show inherited parameters because we're only interested in the ones for the ingestion. So what we'll want to do now is we could have a choice between including specific table names. So for example, here, we could just have a schema.table name as a comma separated list. Because I'm a little bit lazy, I'm just going to simply click edit on the regex one. I'll copy the example because I'm just going to pull everything from our replicate schema. So if I type in replicate, because that was the name of the schema we set up when we were adding the tables. So I'll click OK here. Additionally, you could select your ingestion type. There's a few different options here, but in my case, I'm going to keep it simple with full. Now, this merge task cron schedule is a way to, it's not a way to control how quickly the ingestion happens. The ingestion of the actual data happens through Snowpipe streaming, which is the most cost-effective way to load data into Snowflake. This is actually the schedule in which we will take the data from a staging table that you don't necessarily see and load it into the table you do see, which is the final table, or really the table where all of the changes have been merged into. Hence the name, the merge task schedule cron. Now, in this case, I'm just going to keep it super simple and keep the default there. But you could always change this to hours, minutes, and a specific cron schedule. We'll keep it case sensitive here, and we'll click apply on the final portion. So we can see we've got a red light here. This does not mean a red box. This does not mean anything has gone wrong. It just simply means that that connector is in a ready state, or really that processor is in a ready state. It's just stopped, hence the red stop box. We'll click close here, and we're ready to go. So what we'll do is we'll simply enable all controller services first as the first step. And so you'll see those warning labels go away. And in the next step, what we'll want to do is simply click start. Now, what this will do is it will basically start the connector and all the processes that are underneath it and load that data into our Snowflake table. So we'll give it a little time. If you are interested in seeing kind of what's going on underneath the hood, you could always go into the connector and kind of see the different steps. But in this case, you don't have to worry about any of that because this connector has been fully built by Snowflake already. So if I go back, you can see that it already has transferred some data. It's still loading a little bit, but we can head back to our Snowflake and see the tables. So if I go to our catalog and our raw area, you can now see we have a schema called replicate. Perfect. So let's go into that. We could see we could go to tables, and we could see that we've got orders, products, and users. Those three tables we created when we were inside of pgadmin. And if we click on orders and go to data preview, you could also see that we have all of the columns that we added, and additionally some columns or metadata columns to see, hey, when was this inserted, updated, and if it's a soft delete scenario, it will showcase here of that soft delete happening. Awesome. So this has been loading data from Postgres or RDS Postgres into Snowflake using OpenFlow. Thanks for watching. Bye.